We're going to talk now about how we synthesize aldehydes and ketones. First reaction you're probably familiar with is preparing from alcohols. So if I start with a primary alcohol, that's primary, right? I can prepare aldehydes by doing oxidation reactions. But here I need to use not any oxidizing agent, but they need to be mild. For that, we need to use, for example, pyridinium chlorochromate, VCC, or DMP, or DMSO. Double oxidize to the aldehyde. You cannot use Jones, so chromic acid, because the primary alcohol will continue to oxidize to the carboxylic acid. So here is a carboxylic acid. So we're not using Jones for that reason. So if you have a primary alcohol and you want an aldehyde, you use either these three conditions. And here I want you to remember what is Jones? Jones is chromic acid. And again, you will not use it here because you will get the carboxylic acid, but Jones is chromic acid. And you can make it more than one way. You can do it with chromium trioxide and sulfuric acid. Now let's say, well, I don't want to go this back. H2SO4, that's one way of making it. The other way is using sodium dichromate, sulfuric acid. Either way, you make chromic acid. That's a strong oxidizing agent. We're not using that because that will produce the carboxylic acid. And here we want to make an aldehyde. Now, if you start, this is from primary alcohols. If you start now from a secondary alcohol, let's throw here any other group, methyl, ethyl, anything you want. The secondary alcohol, remember that's your alpha carbon, has two R groups, uses your alpha carbon. Okay. So regardless of the oxidizing agent that you use, you will always get a ketone. So here you can use Jones or any of these. And typically we use more Jones, easier. But either one of these will work to give you a ketone from a secondary alcohol. So again, you can make aldehydes from primary alcohol oxidation doing these oxidizing agents, or ketones from secondary alcohols. So that's one way of synthesizing those. Another important way of making aldehydes and ketones is from the ozonolysis of alkenes. So let me say here, this is alcohol oxidation. That is the first method. Second, we're going to say ozonolysis of alkenes. So depending on the alkene, we're going to get one product or the other. So let's draw that. Say that I have this. This is 1, 2, 3, and 4. This is actually cis-2-butene. And now I'm going to draw this. All right. Not getting enough ink. Say that I have now this. And this is the trans-2-butene. Let's just remove the hydrogens to keep you guys always need to keep that in mind, but I don't want to draw the hydrogens so you see better. This is the cis-2-butene, and this is a trans 2-butene. Okay, if you did ozonolysis, so here, conditions are going to be ozone and followed by DMS dimethyl sulfide. Okay, if you do ozonolysis here, you're going to break this bond here. So you're going to get 2 moles of acetaldehyde. So I'm going to put a number 2. Notice that's an H and H. So you get 2 moles of the same. But if you did the ozonolysis from trans 2-butane, 1, 2, 3, and 4, you're also going to get 2 moles of the same aldehyde. So notice you're breaking that double bond here, and your carbonyl compound then will have this, and that is the same acetaldehyde. So regardless whether you start from the cis or the trans 2-butene, you're going to get the same. Now, here you're making aldehydes. And notice that to make aldehydes, I need to have H's, at least one H. Let's do another molecule. Let's do that. So if I do this 1, 2, 3, and 4, this is going to be 2-methyl, and that is 2-butene. And that here, yeah, this substituents are the same, so we don't have E or C or C strands. Okay, now, what are we getting when we do the ozonolysis of that compound? When you do the ozonolysis of that compound, you're going to get 2 different things because the substitution on this side of the double bond is different to that. So you are going to get by ozonolysis, you're going to get 1 mole of acetaldehyde, and you're going to get acetone. So 2 different products. So if you want to have one product, you need to have asymmetrical substitution. So here, because you had a metal H, you have 2 moles of the same. Here, the stereochemistry was different, but at each carbon you had a H and a metal, and here an H and a metal. So you obtain 2 moles of the same. So depending on the starting material, you're going to get different things. Now, how do we get just, say, acetone? How do we do that? Well, now we need to pick different alkene to do the ozonolysis. So if I wanted to make 2 moles of acetone, I need to start from another alkene. So if I start from this one, now I have the same substitution, metal on each side of the double bond, and upon ozonolysis, I am going to get 2 moles of acetone, right? And regarding name, just to keep track of what we're doing, this is 1, 2, 3, and 4. This is going to be 2,3 dimethyl, 2,3 dimethyl 2-butene. Okay, so recap again. We saw one method of making aldehydes and ketones. The first one was oxidation of alcohols. If you're doing an aldehyde, you need to oxidize a primary alcohol and use a mild oxidant reagent, such as PCC or DMP. And if you're making a ketone, you start from a secondary alcohol, and you can use any oxidizing agent. Now, we can also make aldehydes and ketones from the ozonolysis of alkenes. Depending on the substitution pattern in the double bond, you're going to get alkenes or aldehydes. And I gave you a few examples of how you do that.